Hello everyone. In this video, I would like to discuss solutions for power electronics questions given in GATE 2023 exam. Now let us go into the video. The first question from this paper is the chopper circuit shown in the figure 1 feeds power to a 5 ampere DC current source. So indirectly you can also consider this is a constant current load or current stiff load. The switching frequency of the chopper is 100 kilohertz. That means one cycle time is 10 microseconds. That is also given in the waveform. All components can be assumed to be ideal. The gate signals of the switches S1 and S2 are also shown in the figure. Now the question is, what is the average voltage across that 5 ampere current source is? Now, for example, if I consider this load terminals as X and Y. Now we also given with the waveforms, switching signals for S1 and S2 waveforms are given. So from this waveforms broadly we can understand from 0 to 3 microsecond S1 is turned on and 5 to 8 microsecond S2 is turned on. Now if you see this circuit diagram, suppose if S1 is turned on, then what will happen? This load terminal X will connected to, say for example, source voltage terminals, let us talk it A and B. Whenever S1 is turned on, then this X terminal will be connected to A. In that case, voltage across voltage across XY terminals will be equal to source voltage. Okay, that means from 0 to 3 microsecond output voltage, this is the waveform for output voltage, this is equal to 20 volt, which is same as the source voltage. Next, from 3 to 5 microsecond, no signal for none of these switches, therefore S1, neither S1 nor S2 will be turned on. And from 5 microsecond to 8 microsecond, S2 is turned on. So whenever S2 is turned on, then what happens? X terminal will be directly connected to Y, and hence it is simply something like a freewheeling action. Therefore, voltage between XY terminals becomes 0. So from 5 microsecond to 10 microsecond, we will not get any output voltage. Okay. Again, the same waveform will repeat periodically in the next cycle. So one cycle time is 10 microsecond. Now finally, from this waveform, we have to find out average output voltage. So I can say V0 average is equal to area under the waveform. Area under the waveform is 20 multiplied with 3 microsecond divided by 1 cycle time. So this is equal to 6 volt. So this is a very simple question given for 1 mark. That is, answer will be 6 volt. Now let us look into the next question. So this is also another simple problem, 1 mark question, but this is for MSQ. MSQ means there can be more than one answer, or one or more than one answer, but not all the answers. Okay. So a semiconductor switch needs to block voltage V of only one polarity. That means you need to identify unipolar switch from the given options during turn off state as shown in figure 1, and carry current in both the directions during on state as shown in figure 2. That means based on this figure 1 and 2, you need to identify unipolar and bidirectional switch. You need to identify unipolar and bidirectional switch. Okay. Now let us come to one by one the options. Option A, it is simply transistor with a diode in anti-parallel. Therefore, this switch can block voltage of one polarity between the terminals P and Q. Then it is satisfies unipolar property, and when the transistor is in the conduction state, it can carry current in this direction. When this diode is in conduction, the current can flow from Q to P. Therefore, option A will satisfy for the given requirement. Okay. Now next one, coming to B. Now let us talk about a voltage later. So this switch can carry the current always from Q to P only, right? It cannot carry the current in this direction. It cannot carry that. Therefore, this switch is not suitable our requirement. So ignore it. Now, in this case, this current, this switch can carry current only in this direction, and the reverse direction is not possible. Okay. So B and C also not suitable for the given option, requirement. Now, in this case, current can flow from P to Q. Current can also flow from Q to P. Okay. And the voltage across the switch will be simply positive voltage, right? Unipolar voltage. Therefore, option D is also suitable for the given question. So there are two options are correct, that is A and D. Now let us go to another question. Now this question requires a little bit analysis. So let us do it this analysis one by one. Okay. So what is given here? The circuit shown in the figure has reached a steady state with thyristor T in off condition. Okay. When the thyristor T is in the off condition, circuit is in the steady state. Assume that the latching and holding currents of the thyristor are 0, okay, ideal conditions. Next, the thyristor is turned on at t is equal to 0. Now, what is the duration in microsecond for which the thyristor would conduct? So, you have to find out conduction time of thyristor, okay, conduction time of thyristor. Now, let us say conduction time T on. What is a T on, right? How much time SCR will be in the conduction state. Now, suppose if initially, let us assume that this thyristor is in the off state, therefore capacitor will be charged to source voltage as shown in this figure. Okay, initially thyristor is in the off state and the capacitor is charged to source voltage with this polarity. Now, suppose under this condition, if thyristor is triggered, then what happens? There will be two components of currents that can flow through this device. One is SCR current, let me call it IA. Another is this resonant current, let us call it IC. Resonant current IC. Therefore, how can you define here current flowing through SCR? It is simply source voltage, let us call it VDC, divided by this load resistance. That will be 100 divided by 4 is equal to 25 ampere. 100 divided by 4 is equal to 25 ampere. Now, there is another component, that is IC is equal to, let us say, IC peak sin omega t in ampere. Okay. So, what is the IC peak here? Where, because whenever initial capacitor voltage is some voltage, let us say 100 volt, and LC circuit, okay, then there will be resonant component of current will flow, where IC peak is equal to source voltage or initial voltage across the capacitor multiplied with root of C by L. Source voltage is 100 and capacitance value is given 1 microfarad, inductance value is given 4 microfarad. So, sorry, 4 microhenry. Therefore, this is equal to IC peak will give you 50 ampere. Okay, IC peak is equal to 50 ampere. And what is omega? Omega is equal to 1 by under root LC. So, by substituting this, we will get 0.5 into 10 power 6 in radian per second. Okay. Therefore, capacitor current, how can you write? 50 into sine of omega t. Okay, sine of 0.5 into 10 power 6 t in ampere. 0.5 into 10 power 6 t in ampere. Now, if you look into this capacitor current waveform, how do we have? This is a sinusoidal component, and after now say for example, let us say this time is t1. Okay, after t1, capacitor current will try to reverse due to sinusoidal property. Okay, therefore, if SCR, suppose if SCR is triggered here, T is on here, from here it will start, SCR conduction will start, and SCR conduction will be until, okay, now there are two components of currents flowing through SCR. So as whenever IC reverses, okay, whenever IC reverses, then up to how much time SCR will conduct until that IC is equal to equivalent opposite component of the SCR current, that is the 25 ampere, okay. So SCR will conduct, okay, in other words T is off here. At this point of time, capacitor current should be equal to 25 ampere, okay. At this point of time, capacitor current should be equal to 25 ampere. Now say for example, let me say this instant is a T2, so this instant can be pi by omega, okay, pi by omega, up to 0 to T1, that interval can be pi by omega. Therefore now I can write it like this: SCR can turn off, SCR can turn off whenever IC is equal to 25 ampere. What do you mean by that? SCR current is 50 sine of, now I can write it like this: sine of omega into T2 minus T1 is equal to 25, okay. Therefore this interval can be omega into T2 minus T1 is equal to pi by 6, pi by 6. Therefore what is the total conduction time for, therefore conduction time for SCR, conduction time for SCR from 0 to T1, okay. So that will be, I can say that pi by omega or pi into root of LC plus T1 to T2 pi by 6 divided by omega. So I can also write here LC. Therefore if I take root of LC common, then it will be pi plus pi by 6, okay. So root of LC, if you substitute the components, inductance is 4 microhenry, capacitance is 1 microfarad into pi plus pi by 6. This value is coming around 7.33 microsecond, okay. So for the given question, the answer will be 7.33 microsecond. This much time thyristor will be in conduction, okay. This is a good question. Of course this question is from commutation circuits concept. This, in order to solve this type of problem, student require good understanding in the circuit analysis. So if you quickly recap, what is the basic idea here? Whenever SCR is turned on, the component of 25 ampere will flow, and when IC is when this SCR is turned on, because of LC circuit, a resonant component will form, resonant circuit will be formed, that will have a sinusoidal component. Whenever that sinusoidal component is equal and opposite to the 25 ampere, at that time SCR will get turned off. So so it is triggered at T is equal to 0. From that instant until T2, SCR will be in conduction period. So that is the solution. Now there is another question here. A single phase rectifier consisting of 3 thyristors. Normally it will have 4 thyristors, but the question is nicely framed with the 3 thyristors, 1 diode. Feeds power to a 10 ampere constant current load. T1 and T3 are fired at alpha is equal to 60 degree, and T2 is fired at alpha is equal to 240 degree. So you can also say that T3 is this T2 is fired at pi plus alpha, okay. Now the reference for alpha is positive 0 crossing of V in, that is a sinusoidal source voltage. Now what is the question here? Find the average voltage across the load in volt, okay. Now if you observe these circuit diagram, T1 and D1 are in common cathode configuration, T2 and T3 are in common anode configuration. So at omega t is equal to alpha, whenever T1 and T3 are triggered, then output voltage will be simply follows source voltage. I will show you the waveform also. Now, immediately after pi, D1 will start, D1 will start conduction. The moment D1 starts conduction, then T1 will get turn off. Okay. Therefore, D1 will start from pi itself, but T3 will get turn off only after T2 is turned on, that is at pi plus alpha. Therefore, pi to pi plus alpha, this circuit will give you freewheeling action due to D1 and T3 conduction interval. Next, at pi plus alpha, then what happens? T2 is triggered. Whenever T2 is triggered, T3 will get turn off. So already D1 is conducting. So D1 and T2 will carry conduction until pi plus alpha. Therefore, with this explanation, if you draw the output voltage waveform, it looks like this. Okay, output voltage waveform of the circuit will be something like this. Now, the simple only concept in this problem is you should able to draw the waveform here. At omega t is equal to alpha, T1, T3 devices are triggered. Therefore, output voltage will be followed by VAB. This is a VAB. So, this is a VAB. Okay. So, what is A and B here? A and B are these terminals. Next, at pi, after pi, then what happens? D1 will start conduction, but T3 will not turn off due to constant current load. Okay. T3 will turn off only after T2 is triggered. Therefore, from pi to pi plus alpha, D1 and T3, these two devices will be in conduction, and that will give you freewheeling action. Next, at pi plus alpha, T2 is triggered. Therefore, D1 and T2 will carry the conduction until this is a 2 pi plus alpha. That is a 2 pi plus alpha. Therefore, with this output voltage, average value, it can be defined like this: 1 by 2 pi integration from alpha to pi Vm sin omega t d omega t plus pi plus alpha to 2 pi plus alpha minus Vm sin omega t d omega t. So, why minus Vm? Because these dotted lines are VBA waveform. Okay. So, you can take Vm outside. So, Vm by 2 pi into minus cos omega t, and you have to substitute the limits alpha to pi, and second term minus of minus plus cos of omega t. This is from pi plus alpha to 2 pi plus alpha. Okay. So, generally I used to explain these circuits in my regular class. Who is following my regular class, they are well familiar with this. Here also I explained the concept in detail. So, this simplification will give you Vm by 2 pi into 1 plus 3 cos alpha. Okay. So, source voltage is given, Vm value is 100 divided by 2 pi into 1 plus 3 into alpha is given 60 degree. So, cos 60 will be 1 by 2. Okay. So, this answer, if you calculate this value, it is equal to 39.79 volt. So, for this question, the answer is 39.79 volt. Okay. So, these are all the questions given in GATE 2023 from Power Electronics Specialization. So, with this, I will conclude this video. Thank you for watching. I am a faculty at Omen Institute. I am Shankar. I passed out from IIT Kanpur MTech. I am working as a Power Electronics and Control Systems faculty at Omen Institute, Hyderabad. If you are interested in GATE coaching or various state level PSUs, you can call the number showing on the screen. If you not yet subscribe my channel, you please subscribe so that you will get the notification whenever I am uploading videos. So, my channel is purely educational purpose. I am planning to upload all these subject videos as well as some motivational videos also. Thank you for watching.